So in my last video, I asked the question, why does 2 plus 2.5 sometimes equal 5? And I just realized that I never gave you guys an answer on that. So welcome back to the world of significant figures. Hello and welcome back to Fast Physics, where I try to talk quick and stutter less. In hopes of achieving those two goals, I'm going to be calling significant figures sig figs once again. Let me reintroduce myself. Hi, my name is Maggie. I'm a whole 190 months old, and my favorite color is green. I made a video covering sig figs earlier, so check it out if you haven't seen it yet. But today we're going to be covering sig figs and calculations in things like, addition, subtraction, multiplication, division, which are some pretty important things. But let's do a quick review of sig figs. Sig figs are the digits in a measurement that determine how accurate that measurement is, and there are a few basic rules on how to find them. Non-zero numbers, zeros between non-zero numbers, and trailing zeros where there is a decimal are always significant, whereas leading zeros and trailing zeros where there is no decimal are never significant. We can also use the Atlantic-Pacific rule, which goes like this. Once we're presented with a number, we look to see whether there is a decimal or there isn't. If the decimal is present, we start in the Pacific or on the left, and we don't start counting sig figs until we reach our first non-zero digit. Then once we get there, we count that digit and all the digits that follow it to the right. If the decimal is absent, we start in the Atlantic and we don't start counting sig figs until we reach our first non-zero digit. Once we get there, we count that digit and all the digits that follow it to the left. Sound good? Well, let's hop into it. Now that we've reviewed using sig figs, let's learn how to use them in calculations. That brings up the question, why do we even use sig figs in calculations? Well, let me create this scenario for you guys. You are inviting Bill and Jill to a party and you tell them to bring pizza from Domino's, which always cuts their pizzas into exactly 8 slices. Bill calls you to say that he has about half of a pizza in his truck, whereas Jill calls to say that she has exactly 7 slices of pizza and 3/4 of a carton of ice cream in her car on the way to your house. So how much pizza should you tell your guests to expect? Well, you couldn't really say exactly 1 pizza and 3 slices, because even though Jill was super specific, Bill wasn't nearly as specific. His half of a pizza could mean exactly 4 slices, or it could mean 3 slices, or it could even mean 5. The best you could do without lying to your guests is to say that you have about 1 pizza and a little bit more arriving at your house. Just like the amount of pizza at your party can only be as specific as Bill's very unspecific answer, or just as a chain is only as strong as its weakest link, a calculation made off of measurements can only be as precise as the least precise measurement. What do I mean by that? Well, that means different things in addition and subtraction, and multiplication and division. In addition and subtraction, we round our answer based on the number that went into our calculation that had the least number of decimal places. So for example, if we had a number that went on to the 100th place and one that only went on to the 10th place, we would round our answer to the 10ths because it's less precise. Now that can be a little bit hard to know at first glance, but let's look at a little trick that Arabic numerals afford us. So if we take a look at this question here, it's not immediately apparent which number has the least number of decimal places. Sure, it's only 2 numbers, so it's easy enough to see once we look closely at it. But when we have more numbers, like say 5 numbers, it gets a little bit hard to determine which has the least number of decimal places. So we can use this trick to look at it. So one of the great things about Arabic numerals is that we can line them up and all the place values line up. Well, when we look at a calculation like this, it's super easy to tell which one has the least number of decimal places. We look at the columns and we immediately see that the 3 is alone in the hundredths column. So we should be rounding our answer to the 10th place. So the answer to this problem would be 1.4. Let's do another one to practice. So in this problem, we have 3 numbers, right? In our earlier problem, it was pretty easy to see, without even lining them up, which number had the least number of decimal places. It's a little bit harder to see that when we have more numbers involved. So let's write these numbers in a row. Once we have our numbers written like this, it's super evident that even though 3.7 and 0.4 have numbers in the 10th place, 51 obviously doesn't. The smallest place value that it has is in the ones place, a 1. So even though the answer to this problem, if we didn't round, would be 55.1, we're forced to round it to 55, since 51 has the least number of decimal places. Sound good? Let's move on to multiplication and division. One of the things that I really love about adding and subtracting with sig figs is that you actually don't have to count sig figs. Unfortunately for multiplication and division, you do, but you don't have to line the numbers up, because in multiplication and division, The least precise number is just the number that has the least amount of sig figs. If, for example, we're multiplying two numbers, one of which has 2 sig figs and one of which has 3, we round our answer to 2 sig figs because that was the least precise of the measurements that went into the calculation. Let's do a bit to practice. So if we look at these two numbers here, we have to first count sig figs. 20 doesn't have a decimal, it's absent, so we start in the Atlantic and we don't count the 0, but we do count the 2. So 20 has 1 sig fig, whereas 0.5, as it's written here, has a decimal, so we start in the Pacific. And we don't count this 0, but we count the 5. So both of these numbers actually do have 1 sig fig, so our answer will definitely only be rounded to 1 sig fig. So what's 20 times 0.5? 10, right? So in this problem, there's actually nothing that we have to do to our answer. So this one was definitely an easier problem. Let's try something with division. If we look at our question here, 550 divided by 5 should be 110, right? But because 5 only has 1 sig fig, we're forced to round 110 to 1 sig fig too. So our answer has to be 100, where the 1 is the only significant figure. That wasn't awful, right? Now we can go on to the rest of physics knowing how to use sig figs. I hope that you guys enjoyed this video and that you'll continue to explore physics with me. If you like this video, like and subscribe and turn on post notifications to find out when I post new videos. Bye!